next problem was asked in 2002 again. A straight bar is fixed at the edges A and B. Its elastic modulus is E and cross section is A. There is a load P 120 Newton acting at C. Then we need to find out the reactions at the ends. Okay. So here this is the bar AB which is fixed at the both ends, and at the point C, we applied force 120 Newton. Okay, then we need to find out the reaction forces at A and reaction forces at B. See here, it is trying to pull this body in this direction, so that generally the reaction force at A is in the opposite direction of this RA, and here it is trying to push against the support B. Then this will be RB. Okay, that is how generally we visualize and take that, and at the end we will see whether it is really in those directions or at in the different directions. How we see based on the plus or negative values that you get at the end. So here I need to divide this body, to see individually what are the forces that are acting in the for example, this whole body is 1. I want to see at different blocks what is the forces that are acting. Okay, the entire definition of the stress is based on that. Okay, so here what I do is I will take 2 sections. Okay, how to divide this? This is AC and this is a CB. How to do this? How I divided exactly at C? Why not at any other point? Instead of L and 2L, I will say that it is a 1.5 L and another one is 1.5 L. That means I have taken the geometrical middle of the block. Okay, can I take like that? So see here, always you need to remember that how you need to divide the block. It is based on the point where you are applying the force here. For example, here in this case where you are applying the force at the point C. That is why I divided this block into 2 sections, at C. Okay, at C. For example, instead of C, if I have the additional point D, here let's say additional point D is here, and here also I am applying some force P. Then in that case, how to do the division? Instead of 2, we need to do 3 division. That is A to C, C to D, and D to B. Okay. So if you have a point E at which you are applying one more force, then it will become 4 parts. Okay. The entire AB should be divided into 4 parts. That means here the division of the block AB is not based on the geometrical symmetry or any other thing, but it is based on the number of forces that are applied. Okay, here. So here the number of forces that are applied inside is only at the point C. That is why I divided this into the AC and the CB. So here, how to see? This is the RA. And how to calculate the forces that are acting on the cross section C here. And this is one more important thing you need to remember. You please write down in our notebook also. What is that? How to calculate in this scenario? See, always you need to calculate the forces on any cross section like this. You take that point plus beyond that point. For example, if I take this cross section AC and I want to find out the forces on the C, then on that C and beyond that. Here in this case, the beyond that C is the right side of the rod. That means here on the P, how much acting? On the C, how much acting? P and right side. If you add the right side, then RB also coming in that case. Okay, so here P minus RB. Why RB negative? Because it is acting in the opposite direction. Okay, and here coming to the section CB, how much force is acting on the B? Only one force, that is a RB. And how much force that is acting on the C? Here in this case, like CB, I need to take forces on the C and beyond C. So here if I take this C and beyond C, here the beyond C is nothing but the left side. In case of AC, the beyond C is the right side. In case of CB, the beyond C is the left side. Okay, hope you understood. Okay, so left side. So here how many forces that are acting on the left side? One is at the point C and another one is at the cross section A. So here P minus RA. Okay, This is how we need to write the forces. Okay, so here this is how you need to write the forces, and if I take any of the block section, all this division is based on what? Everything should be in the equilibrium. Okay, you go back and see our introductory video how we derived, like what is the main concept, how we are able to apply the force equation and everything. It is simply based on the equilibrium condition. Okay, so what is the meaning of that? If you take any block individually, then everything should be in the equilibrium condition. So here if I take this, then RA plus RB equal to P. That is how we are getting. Okay, what is the meaning of that? RA should be equal to P minus RB. So I can write RA plus RB equal to P, that is a 120 Newton. Okay, this is the one equilibrium condition. And any other equilibrium condition that you can deduce here? No. And here if you observe how many variables are there, there are two variables. We need to find out the RA and RB, and how many equations are there? So far only one equation. So that means it is a statically indeterminate. So in such cases we need to find some other extra condition, so that you can find out a definite value for this. So what is the extra condition that is here? It is based on the geometry in the sense the conditions, like this is fixed at A and B. That means even though I apply some forces here, the total deflection is 0. That means whatever elongation that is happening in ESE, elongation, why elongation? Because it is a tensile force. Whatever elongation that is happening in the ESE will become whatever contraction that is happening in the CB. Okay, that means here I can write one more thing, that is a delta AC equal to delta BC. Okay, so what is the formula here? Delta AC, the same thing, FL by AE. AE is the same in both cases. So only F and L are different. So F means here RA. RA into L divided by AE equal to RB into 2L divided by AE. Okay, that means RA equal to 3RB. Okay, this is the thing we derived here. And here if you observe, RA is a tensile and RB is a compressive. Okay, here in the problem itself I consider this in the compressive direction and this is in the tensile. So you no need to worry about the negative or positive sign here. Okay, why? Because that is how I considered here directly. Okay. Otherwise, instead of considering the relation in this manner, you can consider like the total deflection is 0. The total deflection means delta AC plus delta BC equal to 0. When you consider this total elongation, not deflection, again and again I am using the deflection, so the total deflection is 0. So when I use this such formula here, that means we expected to take care about the, if we are writing like this, we are expected to take care about the tensile and compressive forces. Here in this case, since we are using compressive, you need to substitute minus and here a negative. Okay, otherwise if you write directly like this, then you don't need to worry. So if I substitute this value here, then what happened? 3RB equal to 120. That means RB equal to how much? 40, and RA equal to 80 Newton and 40 Newton. And what is this? RA is the tensile and RB is the compressor. Okay, so that is how we need to do this. So what is the option here? So the option in this case is D. Option is D. So again I will quickly review this. See here, the basic points that we need to remember is like there are two unknowns and only one equation. So we need some other extra equation to solve this. Why? Because it is a statically indeterminate. Okay, statically determinate, independent. The question can be asked directly on that concept itself. So how to get the extra equation? we need to make use like a, the elongation in AC because of the tensile force should become equal to the contraction in the CB because of the contraction. Okay, otherwise here also if you take the tensile instead of these values, then the total elongation should become 0. That is the case. Okay, so what is happening here, and how to divide these, how to divide the rod AB into different sections? It is based on the number of forces that are applied inside, but not based on the any other geometrical consideration. Okay, so you applied this. And one more concept that I emphasized is like how to calculate the forces that are acting on the C in case of ESE. That is the forces acting on that particular cross section and beyond that. Okay, so that is how we calculated this. Okay, this is to understand that. And in the examination, how to do this? In the examination, how to do this? Okay, in the examination, see here, in the examination, how to do this quickly? First thing is like a RA plus RB should become a 120. So all the options are becoming 120 here. Okay, so the next thing we need to reduce the we need to reduce this. Okay, this is sorry, this is not 3, this is a 2. Okay, RA equal to 2 RB, and this relation you need to deduce, then only you can further verify the options. So instead of that, if you substitute, you can directly get that. Okay, there is no other way. You need to do quickly like this because the logic is simple here. Okay.